Welcome, everybody. See some new faces. If you have any agenda topics you'd like to discuss, please update the deck. Yuval, would you like to start the first one?
Okay. Yeah. So I want to present a small project that I did with some students. It was like their in the university course, really small, but I think really nice. So the project targets the kind of IoT industrial space where you have MQTT as the main protocol. And in some cases you want to, so some of this information is needed for the short-term management of data, but some of it need to be stored for later for data scientists or for machine learning training or something else that needs to have a long-term access to the data. And S3 sounds like a good option for these kind of use cases. The problem is that MQTT is really designed for very small messages. So messages in MQTT are like, probes and sensors measuring voltage, temperature, all kinds of things like that. And they usually send messages that have a very small payload. It's a very efficient protocol with very low overhead. And if we just naively take those messages and put them as objects in S3, that's going to become an extremely inefficient process. So the idea is was to write a converter that aggregates those MQTT messages into objects and according to some configuration policy, stores them as S3 objects. So this was the project, and I have a quick demo showing how it works. Let's first look at the configuration of this small converter. So in the configuration, you have a couple of things. You need to define the MQTT broker, and here the Mosquito project has a very nice service for who wants to try it out. They don't need to install a Mosquito broker on their laptop or on their machine. You can just use the one that they open up in the cloud for access. Of course, don't send anything sensitive there because it's like everybody can see that. And so this is like kind of one leg of this converter. The other leg is the S3 endpoint. The student actually didn't want to compile Ceph, so they tested that with AWS. It just worked. I compile Ceph every now and then, so I just test it with Ceph and with the Redis gateway. This is the aggregation kind of logic. It could be based on the amount of messages, the size in bytes, time. I don't know. There are a couple of conditions there that you can put together to create how those MQTT messages are being aggregated. And the last piece here is the mapping between buckets and topics. So here, my topic 1 and my topic 2 both go to my bucket. So these are the configurations that are needed. As a side note, because we want to later on containerize everything and make sure everything runs nicely in Kubernetes, the broker and the S3 endpoint are probably going to be removed from the conf file. They're going to be automatically extracted from the Kubernetes configuration, like from their operator. There's a Mosquito operator, and of course there's Rook for the Ceph operator, and that doesn't need to be configured in an OpenShift or Kubernetes environment. But this is just a kind of a manual standalone environment, so I have to configure that. And I'm just going to run this. So it's subscribed to those 2 topics. It doesn't do anything special because it doesn't get any messages. Now here I'm going to use like the Mosquito project has like a client that can do publishing. So I'm going to publish to the test Mosquito server on the web. I'm going to publish to a topic called my topic 1 because this is one of the topics that my converter was is subscribing to, and I'm going to send a hello world message. Now, I also have to remember to create the bucket, because the bridge doesn't create the bucket, so I have to create a bucket called my bucket, because again, this is what the configuration said. And then I'm going to send messages. So you would see that it received the message because it subscribed to this topic, but it doesn't do anything with it, because it says that you need to get 5 messages before you're going to aggregate them into one object. So once I've sent 5 messages, then it created the object and he written the object into the bucket. The object name is time-based, because in most cases, those are going to be used later on to do some time series analysis. So this is how we decided to create the object. And if you can see here, I have a couple of objects, and they all contain 5 messages of the same size, and the name is according to the time. Another small thing that also was part of this project is that there is not the best name, the opener. So we do need to have some kind of logic that helps whoever wants to read those objects and extract them back to the original messages, because the person that writes the application that does the analysis or present it in a graph or something doesn't care that we put that everything in one object. This is just for our efficiency. They want to see the original messages. So as part of the broad project, we've written like a small Python code that, based on the way that we've written the object, we do the extraction. The thing that we do is that we create a small header in the object, and we put the offsets of the different messages together with their timestamps in this header. So with 5 messages, it's really trivial. But I mean, let's say that for efficiency reasons, we want to create very large object with thousands of messages, and the reader doesn't want to read the entire object, then they can use they can read the header of the object and figure out what offsets they're interested at, and then use the range command to fetch only part of the object to be more efficient in what they're looking for. Yeah, this is pretty much it in a nutshell, this small student project, if you have questions. Okay, thanks you.
That is cool. The subject of how to kind of do bulk uploads of small objects or figure out a way to pack them efficiently has come up a couple other times. But I think this is interesting in that it's kind of an application layer thing that's doing the packing.
Yeah, so I mean, because this is specific to MQTT, right? Because those messages have their own meanings and so on, and maybe with other more general packing, you would need some other kind of logic. So I think it does make sense to use it here. The original thinking was not to use it, not to build our own small header in the object, but to use the actual head object, like to use the attributes. But I don't think we had enough space there in the attributes to put enough information, assuming we want to be able to have like a long list of offsets of all the small messages in the object. So the first idea was to use the attributes, but I think they have some kind of a limit in size that was not sufficient.
Yeah, that makes sense. Any other questions or comments on this one?
It appears to me that it's somewhat similar to what multi-part upload, which is what I've been playing with in the last 2 weeks. It has the dedicated meta file, which records where the objects are, just similar to what Yuval said about where the offset should be for each messages. And it also has a list of objects that for each chunks being uploaded, which may be corresponding to the aggregated object Yuval was talking about, grouping multiple messages into a single object. And in such a structure, you achieve it's basically one layer of hierarchy from metadata, from manifest to the actual object, which you can retrieve the individual messages. Of course, many improvement and variant can be derived from there, but I found the similarity somehow in between those two.
Yeah, okay.
Yeah, I think the multipart though is kind of I mean, just built into the fact that you don't want to handle one huge object, and it's pretty generic. It's like later on you kind of forget about all the parts in the multipart.
Right. I'm not
And-
talking about using a multipart for this purpose. I'm talking about how how multipart object is managed behind the scene.
Mhm. Yeah.
Similar to what you have been doing.
Right.
Yeah, and in the Swift API, there's kind of explicit support for manifests of smaller pieces of objects. They call it SLO and DLO.
It seems like it might be interesting to have a multipart-like API that does structured data. So the init would define the structure of the data, and then each of the puts would, fill in that structure. And then you could, list these things and get the header, which would have the structure defined in it, and then read out the structured data from that. There might be a generic way of doing effectively this kind of thing.
Like a virtual directory of some sort. You basically create a directory, you drop the object into a directory. The directory has the metadata, contains all the metadata information for each object, something like that.
Yeah, I mean, I was thinking kind of like a database table, but a directory.
Yeah.
I mean, the analogy works either way, I think.
Yep.
So S3 select is kind of what I think of in terms of that being able to just write the structured data and then query specific parts of it with select statements. So you could do the initial upload as a single part or multi-part.
Right, but I think what Daniel Nishin said is that it's not only the retrieval of the data that could be structured, it's also the upload of the data that could be structured.
Yeah, that was the idea, is the upload of the data could be structured.
But okay. With multi-part, you can init multi-part, and then you can kind of stream in all of the parts in parallel. So in this strategy, we'd still need to figure out how to get the correct ordering, I believe.
Yeah, I mean, I guess you'd probably have to tag the parts with a header that describes which of the pieces of structure it fills, I guess, or something like that. I was thinking of it in the context of what you've all presented, where the data comes in sequentially, and so it wouldn't be parallel. But you're right, multipart is parallel, and you probably have to be able to handle that. Anyway, just a thought.
Very cool. All right, shall we move on? Welcome, Andy.
Hey, thanks for having us. So I'll admit I have some experience with Ceph, but not a tremendous amount. So take anything I say with a grain of salt. But I was sort of helping to facilitate some contact between the Ceph team and the folks at Akamai and Linode. So obviously, Yashin has been looking at a possible mitigation for a problem. I'm assuming everybody is probably familiar with it. In the case of Linode, the probably the biggest challenge that we have related to multi-part orphan objects is that our accounting for billing purposes is incorrect. I think in general, there are a few different scenarios whereby clients inadvertently upload multi-part parts multiple times. I think in many cases it's buggy scripts or that sort of thing. So for some time we've been trying to figure out how to deal with both culling the redundant parts in a time and space effective way, and then also trying to implement some sort of fix that would prevent the issue from occurring. But one of the things we're very sensitive to, Akamai has sort of a long history of taking third party off the shelf software and patching it in ways that are difficult or impossible to upstream later. And so to try to avoid falling back into that trap again, our aim here was to be able to contribute back a fix that that would be generally usable. And so we are sort of in the hacking phase on that now. But I think that when I reached out to Daniel, the real thing I was looking for was some guidance on what sort of a fix might be upstreamable. And then, we later learned in the email thread that there was, a parallel effort underway. And I haven't seen that code yet, so I don't know much about it. But so that's my introductory spiel. I'm not sure where to go from there.
Okay, so just to clarify, we're talking specifically about multi-part parts that are re-uploaded, and we're orphaning data from kind of the previous part.
Right.
This is not about incomplete multi-part uploads that just never get cleaned up.
Right.
Okay. Yeah, so this does sound like what Matt is working on in that PR. But I think it just got complicated and hasn't been finished.
Right.
So I pinged him, but he has a conflict at the moment.
All right. So it seems like maybe a good next step would be to see if he and Yishin can compare notes, because I think it would be helpful for us to know whether the strategy that we're thinking of had been potentially ruled out already, or if it's similar enough to what Matt has been working on, that it might be that we could at least assist with the testing. Or
Yeah. So let's see. I don't understand the design of his work well enough to explain it. Does
Sure.
anybody else here? I'm guessing not, but yeah.
Maybe you can share the PR.
I did link it in the agenda.
Oh, cool.
I can get it in chat too.
Oh, awesome.
So yeah, I think I can ask Matt on the PR itself to just give a high-level description of his design, and maybe you guys can take it from there.
Okay. Yeah, that sounds perfect.
And Yijin is the one that should be the contact. Is there a GitHub name that we can tag you on?
Actually, yeah, I have a GitHub account. It's a EMA77, the YI MA77. Actually, I fork a Ceph there and to play with it.
Awesome.
Great. Okay.
So
maybe
just oh, go ahead.
No, nothing too important. Just maybe a small note is that we recently added the ability to nicely trace multi-part uploads. So if the different parts go to different RGWs and so on, then we added tracing abilities using Jaeger. And there is a specific mechanism there that is geared toward multi-part. So because this is kind of a problem usually for many people. So instead of digging lots of log files on multiple RGWs, you can see the nice tracing. Okay, all the parts, and maybe it'd be easy for you to see. Okay, the same part twice, or a cancel or something that didn't finish, and so on and so forth.
Oh, awesome. Yeah, that would be nice. The question I had is that I knew, sort of based on the name of this call, and then doing a little bit of reading around the the head of the repo right now, is it looks like RGW is getting some refactoring related to like pluggable backends. So if we were to devise a fix that, I think we'd be targeting like 16x now, does that code look radically different following a refactoring, or has the refactoring already occurred? Or
It's mostly been ongoing for, I guess, 3 years now. The meeting is a bit out of date in terms of name.
okay,
Right.
yeah,
It started out as that, but it's now just the general upstream planning and discussion meeting for RGW.
okay, gotcha.
Stuff is generally not difficult to backport.
Okay,
There are some specific areas in which it will be more difficult than others, but this kind of thing probably will not be particularly difficult.
all right. Awesome. I don't think I have any more specific questions, but if anybody at Akamai does, feel free.
I'm good. Having a PR is wonderfully helpful. I'll look into that.
Awesome.
Yeah, I'm good. I think that seems like a really good path forward.
All right. Thanks, folks. I know this one has been an outstanding issue for quite a while, so I appreciate your help pushing it through.
Yeah, no problem.
Hopefully
I
we
know.
can, get a plan in the PR for finishing and verifying the stuff there.
Yeah, it's no problem. After my sort of naive read through of the code, it was I came away realizing what a challenge it would be to address it safely and correctly. So I don't envy you guys for having to do it.
All right. Any other agenda topics? Last call. All right. Well, thanks, everybody. See you next time.
Yeah, thanks for having us.
Thank you.
Yeah, thank
Bye-bye.
you.